In this lecture, I will teach you parallel input serial output mode of shift register. It is a very easy and important topic at the same time. In this mode, the bits are entered in parallel, or you can say simultaneously. We have 4 bits, B0, B1, B2 and B3, and we need to enter them in parallel manner. One very important thing that you can see in this circuit is that the output of the first flip-flop, that is Q0, is connected to the input of the next flip-flop, that is D1, via a combinational circuit. In this combinational circuit, we have 2 AND gates and 1 OR gate. The same combinational circuit is used for the flip-flop number 2 and flip-flop number 3. And we will see the working of this combinational circuit in a minute. There are 2 modes in which this circuit can work. The first one is the load mode, and the second one is the shift mode. And if you see the heading, it says parallel input serial output mode. So we have 2 aims. The first one is the parallel input and the second one is the serial output. So the first aim we will achieve from this first mode, that is the load mode. By the load mode, we have the parallel input of the data, in which we will enter the data or load the data in each of these flip-flops simultaneously. Flip-flop number 0 will have B0, flip-flop number 1 will have B1, flip-flop number 2 will have B2, and flip-flop number 3 will have B3. All these 4 bits are stored in the respective flip-flops during this load mode. So let's see how we can have this load mode. For this, you need this input, that is shift/load complement, and I have used the load complement here because we have loading when the input is low, and this shows that it is an active low signal. So when it is low, it means when it is 0, here I have 1 because of this NOT gate, and here I have a 0. So let's see what are the inputs to the different AND gates that we have used. For the AND gate number 1, the first input will be 0, that you can see from here. For the AND gate number 2, we have the first input as 1. Similarly, for 3 we have 0, for 4 we have 1, 5 we have 0, and 6 we have a 1. And the another input for the AND gate number 1 is Q0. So we have output as 0, because Q0 and 0 will give us 0. Whereas for the AND gate number 2, the another input is B1, and 1 and B1 will give us B1. Similarly, we have 0 here, B2 here, 0 here, and B3 as the output of the AND gate number 6. Now we have OR gate, and 0 or B1. 0 or B1 is simply equal to B1. So we have B1 as the input to the flip-flop number 1. Similarly, B2 as the input to flip-flop number 2, and B3 as the input to flip-flop number 3. So you can see that we have B0 stored in flip-flop number 0, B1 stored in flip-flop number 1, B2 in second flip-flop, B3 in third flip-flop. So it is a very easy operation. The load mode we have done, and the data is now stored in the flip-flops. What we want next? We want the serial movement of the data. We want the data to go from flip-flop number 0 to flip-flop number 1. In the same way, from 1 to 2 and then 2 to 3. And the data stored in the flip-flop number 3 we want as the output. So this is what we want, and this is our second aim, and it can be achieved by the shift mode. And during the shift mode, we just change this 0. To 1, and because of this we will have a 0 here, 1 at this point, and you have to switch the inputs to your AND gate also. So we have 1 as the first input to gate number 1. In the same way, we have 1 for the gate number 3 and 5, and 0 for the gate number 2, 4 and 6. Because of this, we have some changes. Let's see what they are. First, let me rub this down so that we have some space to write down the changed outputs. Okay, and for the gate number 1, for the AND gate number 1, you can see the another input is Q0 and the first input is 1. So Q0 and 1 will give us Q0. So we have Q0, and the gate number 2 will have output as 0. So this OR gate will give us Q0. Now it is very simple to understand that for this combinational circuit also we have Q1 and here we have Q2. So you can see that the data stored in the flip-flop number 0 is now shifted to flip-flop number 1. Q0 was the output, and now this output Q0 is acting as the input to D1. So whatever be the value of Q0, we have it in the flip-flop number 1. In the same way, Q1 is acting as the input to D2, Q2 is acting as the input to D3, and whatever be the value stored in the third flip-flop is now out. So we have Q3 as the output. And let's take one example. Let's take some random bits and let's see how it moves. If we have 1, 0, 1, 1. So let's see what we have in that case. For the first mode, when the loading of this shift register is done, this 1 is stored in the flip-flop number 0. This 0 will be stored to flip-flop number 1. This 1 will store here, and this one will be stored in the last flip-flop. So we have 1, 0, 1, 1. The parallel storing of the data is done here. And when we have the shift mode, when we change this input to 1, there is shifting of data, and we have output as 1 because 1 was the value stored in the flip-flop number 3. This 1 will now be shifted here, and this 0 will now shifted to flip-flop number 2. So this 1 will now become 0, and this 1 is shifted to flip-flop number 1. So we have 1 here. So you can see the data is first entered in parallel manner. We had 1, 0, 1, 1. Then it is shifted. And we have 1 as the output. This 1 is shifted to flip-flop number 3. This 0 is shifted to flip-flop number 2, and this 1 is then shifted to flip-flop number 1. So this is how the shift register in parallel input serial output mode works. I hope it is clear to you because you have already studied the rest of the 3 modes, that are serial input, serial output, parallel input, parallel output, serial input, parallel output, and now we have also completed the parallel input serial output mode. So there are 2 topics still left in the shift register. The first one is the bidirectional shift register, and the next one is the universal shift register. In the next presentation we will study the bidirectional shift register. So see you in the next one.